Welcome to the Singapore Management University podcast series, which features the latest insights and perspectives from our faculty. The field of software engineering has been developing rapidly in recent years, with the introduction of new platforms, processes, and programming tools to create software products. By analyzing the large amount of data produced during the software lifecycle, software developers are able to improve software development and quality. Such analyses also offer opportunities to create customized solutions that can be used to automate software engineering tasks. Associate Professor David Loh of SMU School of Information Systems is an expert in software analytics. In this podcast, Professor Loh shares with us his research on automating software engineering and its benefits. Professor, could you share with us what it means to automate software engineering and why is there a need to do so?
Engineering a software system involves many tasks. For example, the elicitation of requirements from end users, designing a software product, implementing design into source code, creating test cases to ensure the reliability of a software system, fixing bugs, and actually many more. Unfortunately, many of these tasks are currently done manually with limited automation. Automated software engineering allows these manual software tasks to be done with the help of a software analysis or an artificial intelligence tool. These tools can perform complex analysis and even learn from the big data of software artifacts. For example, the billions of lines of code stored in open repositories like GitHub to help developers perform their job more efficiently and effectively. With it, developers can then spend less time on some of the semi or fully automatable software tasks. Furthermore, the quality of a software can be improved by automatic means. For example, automatic detection of defects, automated detection of bad practices, also known as code smells, and many more. Achieving more automation is particularly important today due to various factors. First, more and more applications and software are needed to help in the various industries that rely on information technology. The need is greater now as compared to, for example, 10 years ago. Second, many emerging technologies today are revolutionizing the market, and these technologies rely on a good software to run. Often, to beat competitors, these pieces of software need to be written quickly, and yet they need to have high quality. Augmenting developer skills with automated software tools can help to accomplish these goals. Third, the cost of employing a software developer is increasing, and the labor force also may not grow as fast as the industry needs. And thus, the need to shift some of the load from developers to automated tools.
How would automating software engineering benefit individuals, businesses, and governments?
Automated software engineering tools can help reduce the load of software developers. Developers can then better channel their energy, enthusiasm, and creativity to create more software products. This will in turn benefit the end users of these products, be it individuals, businesses, or governments. Information and communication industry is one of the pillars of Singapore economy. According to IDA, the Infocom industry generates more than $167 billion in 2014. And in 2015, it employs more than 170,000 people with an annual growth rate of 15%. These numbers may grow further as Singapore strives to be a smart nation in which people are empowered by technology. Automated software engineering can play a substantial role to improve the productivity of IT personnel and businesses, which in turn can boost revenue and contribute to Singapore's economy and smart nation vision.
Can you share with us some of your research in this area? What are the challenges or difficulties associated with this field of study?
I'm leading the Software Analytics Research Group, which currently consists of 15 people, including faculty members, PhD students, and research engineers. As a group, we tackle the challenge of automating software engineering by using software and data analysis techniques. Our group worked on three main areas: analytics for requirement and design validation, analytics for coding and collaboration, and analytics for testing and debugging. In each area, we built automated software engineering solutions to help developers in some aspects of their work. As a more concrete example, let me share a bit more about our work on software defect management. As you may know, software today often comes with defects that need to be managed and resolved. To help developers deal with defects, we have built various solutions. For example, we have built automated solutions that can identify defects in a large software system. For example, the source code of the Linux operating system. We do so by detecting anomalies in a code base. We have also built tools that can help developers make decisions when they process and resolve a defect report. We augment developer skills by a data analytics engine that can inform the developer on, first, whether the defect report is a duplicate one. Note that multiple end users can write reports of the same defect, which causes duplicate reports. Second, it can also inform developer on which defect report should be prioritized. Third, who is the best developer to be assigned to the defect report. Fourth, where the defect is likely to reside in a software code base given the report. And fifth, how to repair the reported defect. Of course, there are challenges in automating software engineering. Let me describe a few of them. First, the pain points of developers and the opportunities for automation need to be identified. Second, data sources that can be analyzed for the automation tasks need to be collected, cleaned, and integrated. Third, suitable software and data analytics solutions that model or take into consideration developer cognition process need to be designed and developed. And fourth, experiments need to be conducted to evaluate and fine-tune the solutions. Automating the job of software developers is not easy. A 2015 article by BBC, which is based on a research report by a group in the University of Oxford, mentions that programming and software development are among the most difficult jobs to automate. It is ranked 284th out of the 366 jobs that they analyze. This further motivates the need for more research in automated software engineering.
How do you see this field of study developing in the years ahead?
In the years ahead, I foresee more and more software tasks, including difficult ones, to be automated. For example, researchers in MIT and Carnegie Mellon University, and SMU is also having a share, are leading the effort to build solutions that can automatically repair a defective program. If the solution becomes mature, a bulk of software maintenance costs, which is attributed to the removal of defect, will go away or at least be substantially reduced. Moreover, I envision the construction of an internet-scale software analytics solution that can deal with and make sense of gigantic amount of passive software data which are stored in diversified repositories on the internet. With such solution, massive amount of passive software data can holistically be analyzed and collectively be made alive to transform manual, painstaking, and error-prone software engineering tasks to automated activities that can then be performed efficiently and with high quality. This can be done by collecting, linking, and synthesizing the wisdom of the masses accumulated through years of development efforts by thousands of developers, which are hidden in this passive, distributed, and diversified data sources. This would be groundbreaking because no existing software analysis techniques have come close to making sense of large amount of software engineering data in this scale and diversity in a holistic way. The eventual result, I believe, will be a significant productivity and reliability improvements, which will translate to more high-quality application being released for the benefit of the general public. These goals, of course, cannot be realized by one research group alone, but by a community of dedicated researchers. One such community meets annually during the International Conference on Automated Software Engineering, and we are honored to have the opportunity to host the 31st Institute of Electrical and Electronics Engineers and Association of Computing Machinery International Conference on Automated Software Engineering, which is one of the premier software engineering conferences in Singapore. The conference will be held in SMU between September 3rd to 7, 2016, and we are looking forward to welcome experts from all around the world. I'm truly excited to work in this field and to be part of an international research community that endeavors to reach these goals in the years ahead.
Thank you, Professor.
Thank you.